Artificial intelligence is no longer the stuff of science fiction novels or futuristic movies. It's rapidly becoming an integral part of our daily lives, transforming the world as we know it. The possibilities seem limitless, and the potential impact on society is immense. It's here, all around us. From the mundane to the extraordinary, AI is quietly revolutionizing how we live, work, and interact with the world. AI writes articles, crafting compelling narratives and informative pieces with remarkable speed and efficiency. Composes music, generating original scores and melodies that stir the soul and captivate the senses. And even creates art. It produces stunning visuals and thought-provoking pieces that challenge our perceptions of creativity and artistic expression. These smart systems are changing how we work and play, streamlining processes, enhancing productivity, and opening up new avenues for entertainment and leisure, moving at a rapid pace. The speed of innovation is breathtaking, with new breakthroughs and applications emerging constantly. You'll find AI in your smartphone, assisting you with tasks, providing information, and connecting you to the world with unprecedented ease. Powering everyday apps. From navigation to communication, AI enhances the functionality and user experience of countless mobile applications. It's in modern cars, making driving safer, more efficient, and more convenient through advanced driver assistance systems and autonomous driving capabilities. And in smart speakers, answering your questions. These devices provide instant access to information, control your smart home, and offer personalized assistance with just your voice. Doctors and scientists use AI to find diseases, detecting anomalies and patterns in medical images and data that might otherwise go unnoticed, and make discoveries. AI accelerates research, analyzes vast datasets, and identifies new insights that can lead to breakthroughs in medicine, science, and technology. AI is becoming a partner in many fields, augmenting human capabilities, automating tasks, and enabling new forms of collaboration and innovation, promising to solve big problems. From climate change to poverty, AI offers the potential to address some of the world's most pressing challenges. Because AI seems so smart, capable of performing complex tasks and processing vast amounts of information, our expectations are sky high. We envision a future where AI can solve all our problems and create a better world for everyone. We often think it can do almost anything a human can. We see AI as a potential replacement for human labor, a tool for automating complex processes, and a source of endless innovation. When an AI holds a conversation, engaging in natural language interactions and responding to our queries with apparent understanding, it feels human-like, blurring the lines between human and machine and creating a sense of connection and empathy, leading us to assume it understands the world as we do. We project our own thoughts, feelings, and experiences onto AI, attributing to it a level of consciousness and awareness that it may not possess. But this isn't always true. Despite its impressive capabilities, AI is still far from achieving true human-level intelligence. There are surprising gaps in AI's knowledge. It can struggle with common-sense reasoning, abstract concepts, and tasks that require creativity and intuition. Some tasks simple for humans, like understanding sarcasm, recognizing emotions, or adapting to unexpected situations, are unexpectedly hard for AI. These limitations highlight the fundamental differences between human and artificial intelligence. This makes us pause and reconsider. What does AI truly understand? What is the depth of its comprehension? And what are the boundaries of its cognitive abilities? And what does it just mimic? Is it simply regurgitating information and patterns it has learned, or is it truly grasping the underlying meaning and context? These questions matter. They reveal the real limits and potential of AI. Understanding these limitations is crucial for developing responsible and ethical AI systems. Our journey with AI is one of discovery. It's a continuous process of learning, experimentation, and refinement. We must look beyond the hype to see what's real. We need to critically evaluate the claims and promises surrounding AI and focus on its practical applications and limitations. Understanding these limits helps us use AI wisely. It allows us to harness its power for good while mitigating the risks and unintended consequences. The story of AI is still being written. It's a story of innovation, collaboration, and the ongoing quest to understand the nature of intelligence itself. Imagine your advanced AI assistant, brilliant at poetry and science, faces a simple photo. It's an analog clock on a wall. You ask, what time is it? You expect a quick answer, but many top AI models struggle. They can't reliably tell time from an analog clock face. This surprised experts since these AIs can identify cats or describe street scenes instantly, yet a simple clock confuses them. The same goes for calendars. AI might read the numbers, but understanding their meaning in a calendar grid is tough. This is a peculiar blind spot for such powerful systems. AI is trained on vast visual data, recognizing countless objects and patterns, but clocks and calendars present a unique challenge. Understanding time visually is more complex than it seems. It's not just about seeing, it's about interpreting. Reading an analog clock, it's a familiar object, something we've all grown up with. But understanding an analog clock isn't just about seeing lines and numbers. It's more intricate than that. It's about understanding their relationships, the hour and minute hands, their positions relative to each other, and what those positions ultimately mean in the passage of time. It requires a cognitive leap. AI vision models excel at recognizing static patterns. They can identify objects with impressive accuracy, like cars or animals. They are trained on vast data sets to achieve this. But clock hands constantly change. They are in perpetual motion, creating endless new patterns. This dynamic nature poses a significant challenge. AI struggles to connect these fleeting cues, these ever-shifting arrangements, to the abstract concept of time. It's a hurdle that requires more than just pattern recognition. This task requires spatial reasoning, understanding angles, positions, and their meaning within a broader context. It's not enough to see a short line near 10 and a long one near 2. The AI needs to understand the spatial relationship. The AI must interpret this as 10 past 10. It needs to bridge the gap between visual input and conceptual understanding. Calendars pose similar challenges. They present information in a structured yet abstract way. The grid layout represents time, organizing days, weeks, and months in a visual format, but AI often misses the structure. It sees individual elements but struggles to grasp the overall organization. Recognizing numbers is easy. Optical character recognition handles that with ease. Understanding their place in the calendar is hard. It requires understanding context and relationships. The number 15 under Wednesday, seemingly simple, means the 15th day of the month, a specific point in time, a complex symbolic task. It's about associating a number with a day and a position within a larger temporal structure. These visual tools require more than object recognition. They demand a higher level of cognitive processing. They demand deeper interpretation, a capacity for abstract thought, and an understanding of spatial relationships that current AI systems often lack. AI learns from the data it's given, much like we learn from our experiences. The quality and breadth of this data directly influence what the AI can understand and accomplish. It's a process of absorbing information and identifying patterns. Much like a student diligently studying for an exam, the more comprehensive the study materials, the better prepared the student will be. If it's trained mostly on images of animals with countless examples of cats, dogs, and birds, it becomes an animal expert, able to identify species and breeds with impressive accuracy. It can classify animals in different environments and poses, but not a historian. It won't understand the historical context or significance of those animals. For clocks, most training images show them as background objects, often blurred or partially obscured, not the main focus. They're simply part of the scenery, easily overlooked. So AI may recognize a clock, identifying its shape and general features, but not how to read it. It struggles to decipher the meaning behind the position of the hands. To truly learn time-telling, to grasp the relationship between the hands and the hours and minutes, AI needs thousands of labeled images, a comprehensive data set specifically designed for this purpose, showing every possible time, from 1 o'clock to 12:59. Each image must be precisely labeled, with meticulous detail and accuracy, like 3:45 p.m. or 3:45 in the afternoon. Only then can AI connect through its complex neural networks the visual arrangement of hands, the angles and positions, to the concept of time, to the abstract idea of hours, minutes, and seconds passing. The same goes for calendars. AI needs countless labeled images showing various layouts and date configurations to learn how grids relate to days and months, to understand the cyclical nature of time. Without focused, clear, well-labeled data, meticulously organized and categorized, AI lacks the foundation to interpret these tools. The necessary building blocks for understanding are missing. It's like trying to read a language, attempting to decipher symbols and characters without knowing the alphabet. Without the fundamental knowledge of the underlying structure, specialized training is essential, targeted and specific instruction is crucial for true understanding. For AI to truly grasp the nuances and complexities of time. Otherwise, without that specialized training, AI's knowledge remains shallow. It only scratches the surface of true comprehension. Recent studies have tested AI's time-telling skills. Researchers showed advanced AI models simple images of clocks and asked for the time. The results, often surprising and sometimes funny. An AI might see a clock showing 10:10 but answer 2:50 or 7:30 or admit it can't tell. Sometimes it gets distracted by the clock's style or brand, missing the main task. In one study, a leading AI vision model was correct only a small percentage of the time. Digital clocks are easier for AI since recognizing numbers is a strength. But unusual fonts or cluttered backgrounds can still trip it up. With calendars, AI might spot numbers but struggle to find a specific date, like the third Tuesday of July. These errors reveal a significant gap in AI's reasoning. AI's achievements are remarkable. It translates languages, beats world champions at chess and Go, and accelerates scientific discovery. AI writes code, designs proteins, and finds patterns in massive data sets. Yet it often fumbles with tasks a child can do, like reading an analog clock. This contrast is revealing. AI's intelligence is specialized, not human-like. It excels at pattern recognition, but struggles with embodied understanding and common sense. Integrating information in novel ways remains a challenge. Reading a clock exposes these current limits. Humans learn to tell time through lived experience, not just memorizing images. We connect clock hands to daily routines, breakfast, lunch, school ending. This practical experience links visual cues to meaningful events. We learn numbers, counting, and the concept of time's passage. Our understanding is conceptual, not just pattern-based. Calendars are similar. We tie them to birthdays, holidays, and seasons. We grasp the cyclical nature of weeks and months. AI, by contrast, learns from static data sets, missing this rich contextual experience. That's why its understanding is so different. How can AI learn to tell time reliably? One way is better training data, millions of labeled images of clocks and calendars. Another is building AI models with stronger spatial reasoning to understand relationships, not just objects. Multimodal learning, combining images, text, and video, could help AI build deeper understanding. AI may need to grasp abstract concepts like sequence and cycles, requiring new architectures or training methods. This is an active area of research. Progress here could unlock new capabilities for AI. AI's trouble with clocks and calendars isn't just a quirky flaw. It reveals the limits of pattern recognition, no matter how advanced. AI doesn't understand the world as humans do. Human understanding is built on experience and context. AI's is often superficial. This doesn't make AI useless, far from it. But we must be realistic about its strengths and weaknesses. We shouldn't assume AI has human-like common sense. Overcoming challenges like time-telling will mark real progress. Until then, we'll keep learning about intelligence, artificial and our own. And maybe for now, keep an eye on the clock ourselves.